Okay? Okay, so this is finishing up the last section of notes from yesterday. Today is Tuesday, the 27th. Up on the board, I always put the ending times of every hour. So this class ends at 8:11. Not the starting, it's when the class ends. We have electric stapler right up there, okay? There's also pencils in that box. Okay, so we have less than. So is this an and or an or? This is an and problem. I want you to think about it. You see less than, correct? All right? Here's 0, correct? Less than, distance, absolute value means distance, right? So if I want to go, say, 5 units, absolute value less than 5, correct? So I'm going to go 1, 2, 3, 4, 5. So I'm 5 units from 0, correct? So the first one's greater than 5, correct? Correct? Then the second equation we write is to the left how many? 5, correct? But its position on the graph is -5, isn't it? So I go 1, 2, 3, 4, 5. So won't it be less than 0? So that's why your first equation is less than. Your second equation is what? Greater than. Correct? From 0. So like this first equation here is the first one is 2x minus 1 is greater than the opposite signs, correct? The negative side. And 2x minus 1, the second one, is always going to be just copied down without the absolute value. Okay? So add 9 over here, add 1 over there, divide by 11, I get 2 11s, correct? X is greater than 2 11s. Then we do the next one. Let's see here. I'm going to subtract 9x over here, so that gives me -7x. Add 1 over here, which gives me 0. I remember what happens when I divide by both sides of an inequality by negative. What happens to the inequality? You flip it. You reverse the inequality, so now this is going to be x is greater than 0. So we have this. Agreed? And the problem with you divide by negative, where's 0 on the number line? Is it to the right or left of 2 11s? On the number line. It's to the left, right? So here's 0. Here's 1. 2 11s is about right here. Is that correct? Agreed? So when we wrote our inequality, it would be 0 is less than x, which is less than 2 11s. This means the same thing as that, doesn't it? Agreed? So, open circle, and you connect. And that's what ands normally look like. Interval notation would be, this one is tricky. Oh. Anybody catch my mistake? Watch this one. Look at this one. This one was tricky. Think about it. Let's do this. 2 11ths is here. So the first one was x is greater than 2 11ths, correct? It's going this way, isn't it? Agreed? And then x is greater than 0 is right here. So they're not going towards each other this time, are they? Everybody agree with me on that? So that's what happens when you divide by negative. So this one's a little tricky because I want you to look at ands mean where they intersect, correct? Or they share. So which ones do they share down here? Do they intersect down here? Do they share those points? Remember, it has to work for both of them, doesn't it? So the only place it works is where? 2 11ths. So it's 2 11ths on. So it would be 2 11ths to positive infinity. And the only thing that works for inequality is this right here. Normally, ands go towards each other, don't they? They intersect. Now, if this was an or, then it would be everything going that way. But an and is only where they share stuff. Okay? That was a tricky one. Questions on that? Were there any in the homework assignments that you had trouble with that I could answer for you right now before I go into the last notes? The last unit. Yeah. You guys speak up. Number what? 4 on which one? 02B? Is that right? You know, I'm always looking for different ways to teach stuff. So I got an email from an online student, and they didn't know how to do interval notation, correct? So I went on, and again, my wife doesn't let me use a hammer on anything because I'll end up having to get somebody to do it anyway, so it'll be twice as bad after I hammer and knock a hole in something. They don't let me use anything mechanical in my house. My wife says, call the man, correct? My dad could do anything. He was a machinist, farmer, hunt, fish, do all that stuff, and he raised 2 boys that couldn't hammer a nail. We were just athletes. Make sense? Correct? So I go on YouTube to figure out how to do stuff. So I found a unit. Yeah. Sure. I found a unit. I just clicked. I went to YouTube and said, lesson on how to do interval notation, and there was a 5-minute lesson on there that was outstanding. So I just copied the link, sent it to her. Oh, great, this is great, Mr. Campbell, thank you. So you kids have such a great advantage to when I went to school 40 years ago, is you can click on anything, and there's a 5 to 10 minute lesson on showing you how to do it. So if it really means something to you, you can figure it out. Correct? If I want to learn how to smoke a brisket on my Traeger, I go smoking the brisket on the Traeger, and there's 10,000 videos on how to do it. And you know something about that brisket after I did that lesson? Man, it was good. And you get a self-satisfaction which you taught yourself. Does that make sense? So you can figure it out if it means something to you. That brisket sure tasted good. Okay, number 4. The absolute value. This is number 4 on today's homework. So I think this is pretty similar to what I just did, isn't it? Correct? Agreed? Is this an and problem? Okay, so the first one, the left side, this is how I remember it. Copy it down, except you're going to reverse inequality and you're going to change all the signs, correct? That's the negative. That's the left side, isn't it? Correct? Everything's the same. Reverse inequality, change all the signs. The second one, you just copy it down, and get rid of the absolute values. That's how I remember it. Does that make sense? This one here, the left side, reverse inequality, change all the signs. Right side, copy it down without the absolute values. Okay? All right, add 3x over here, subtract 5 over here, divide by 4, I get negative 1/2 when I reduce. Agreed? Okay, this one here, subtract 3x, so that gives me negative 2x, subtract 5 over here, what's that give me? Negative 8, divide by negative 2, so what do I have to do to the inequality? Flip it. So isn't that just what I just did, I thought. Correct? So this is what I have. Now this one here, let's look at it on the number line. This is an and, which means only the points that they share or where they intersect, correct? Okay. So we have negative 1/2, or x is greater than or equal to negative 1/2. So it's going this way, isn't it? Agreed? Why is it a closed circle? You got an equal sign, doesn't it? Okay, this one here at 4. So this is negative 1/2. 4. X is greater than 4, equal to 4. So it's going this way, correct? So do they share anything down here? No. The only thing they share is where? From here over. So then it would be 4 to positive infinity. And the only thing that works is that right there. Get rid of the other. If it was an or, then it would be everything from here over. Does that answer your question? That was just like the one I did, wasn't it? Does that help? Any others? So if you're doing this on your paper, you should know, I told you to highlight the ones that you had trouble with, so those are the ones you review for your final exam, correct? You'll keep those organized, and that'll, instead of reviewing for a final for 2 hours, you review for half an hour. Any other questions? Does that help on that? Yes, sir. What do you got? 7? The other teachers aren't doing this. They're not going through and redoing the homework. They're just lecturing. That's why I'm a little bit behind. Sophia, you know why I don't hear very well? Because I went to too many Metallica concerts. Huh? Oh, sorry. My wife tells me all the time I don't hear very well. I said, well, I hear what I want to hear. She says, go mow the yard. What? I hear you. Here. You go get me a chocolate shake at Basket Rock. Sure, I'll be right back, sweetheart, whatever. God, no one has any fun in here. We can have a little fun, can't we? Okay, the right side, switch it. Correct? So that's the negative side. And then the other one, just copy it down and get rid of the absolute values. Agreed? Okay, add 2x over here. Add 2 over there. So what do I get? 3. Divide by 5. So that's 3/5. You could also use 0.6, correct? If you wanted to. Does everybody know how to change 3/5 to a decimal? 3 divided by 5, correct? All right. And this one here, subtract 2x, add 2. Is that right? Is that correct? All right, so remember, this is a and problem. Why is it an and problem? Right there. Less than, isn't it? So it's where they share in common. All right, so here we go. Why do I use 0.6? Because I think it helps kids understand where it is relative on the number line. Agreed? Okay. All right, so 0.6 is about right here, correct? It's a closed circle going that way. Agreed? Correct? And then x is less than 1. X is less than or equal to 1 is going this way, isn't it? So this thing keeps going. Do they share points out here? No. Do they share points out here? No. They only share these right here. So I can write this one like this. Agreed? And then my interval notation is that. Does that help now on those? Make sense? Okay. All right, now let's talk about tolerance. Okay, so your friend tells you she didn't She isn't sure how much money she has in her account, but she thinks she has $50, give or take $15. Okay? So she thinks she has $50. So the least amount she could have, does everybody agree with me, she thinks would be 50 minus 15, which would be $35. That'd be the least amount she would have, agreed? $35. No, thinking that she has $50 in her account. The greatest amount she could have, thinking she had $50 in her account, would be 50 plus 15, which is 65. Agreed? Correct? Agreed? Does everybody agree with me this is an and problem? Somewhere between 35 and 65. Correct? So when we do this, this is an and problem. So today we're doing applications where x is greater than or equal to 35 and x is less than or equal to 65. Everybody agree with me on that? Correct? So what was the ideal number she thought she had in her account? $50, correct? So couldn't we write our absolute value inequality like this? This right here is the money she thinks she has. You have to subtract, and is less than or equal to what we call the tolerance. Now watch this. Let me solve it. You guys already know how to solve this. Let's see if this works. This is writing the equation given that. Correct? That's writing the equation from that. Yes or no? So if I add 50 there, what do I get? Do I get x is greater than or equal to 35? Do I? And then when I add 50 there, do I get x is less than or equal to 65? Works, doesn't it? Correct? All right, now, a professional baseball player has a bat that's supposed to weigh 5.125 ounces. That's what they hope it weighs. Okay, so like if you're a product manager and they're running all these boxes, let's say of cereal, correct? And they're just going fast. You know, they're running out hundreds of thousands of boxes of the same cereal every day. Are they going to weigh every box? They can't. So they have a certain weight that they want it to weigh, say 16 ounces. So they're going to pull one box out. And they're going to have a tolerance. They're going to say, okay, it's supposed to be 16 ounces, which is 1 pound. They're going to give or take a half an ounce. So if that thing is more than, if it's more than 16 by a half an ounce, then they're going to shut it down and they're going to figure out what's going on, because that's a lot of money when you start running hundreds of thousands of boxes. Does that make sense? So if it's supposed to be 16 ounces and you have a half tolerance, that means it can weigh somewhere between 15 and a half and 16 and a half ounces, yes or no? If the tolerance is half an ounce. If it weighs any more to the right or any more to the left, they got to shut that thing down because something's going wrong. That machine's putting too much cereal or not enough cereal in there. Correct? Does everybody understand what tolerance is? What product managers do? You're saying, well, it's only half an ounce. Well, when you're running 100,000 boxes a day, that's a lot of money. Correct? Okay, have you bought cereal lately? I don't eat cereal, but it's expensive. I can tell you that right now. Everything's expensive. Okay, so, again, the least amount, okay, is 5.125 ounces minus the tolerance, which is 0.0125. That's your tolerance, which gives me 5.1125. That's the least amount that bat can weigh. For my box of cereal, it was 15.5 ounces, wasn't it? Correct? Agreed? The greatest amount it could be would be 5.125 plus the tolerance, which gives me 5.1375. So that's the greatest amount. Does everybody agree with me? My equation is x minus 5.125, absolute value is less than or equal to 0.125. This is what you hope it weighs, and this is your tolerance. Now, can we write our AND equation given these as our least amount? So wouldn't it be written like this? 5.125 is less than or equal to x and less than or equal to 5.1375. Our bat has to weigh between those two values, yes or no? Correct? Yes or no? See what I'm doing? This will always be minus. This will always be less than or equal to. Always when you write these equations. Always. Not sometimes. Always. This will always be x. Always. The two things that will change are where I got the arrows. Okay? This is the equation that we just worked on. Actual minus ideal is less than or equal to tolerance. And the second one, I'll do an example like this one, which is a little bit harder, like that. Okay? So those are what you're going to use. This one we just worked on. This one here, I'm going to show you an example like that. Okay? Makes sense. So, the ideal diameter of a piece of metal is 0.25. So that is what you're hoping it is. With a tolerance of, that's your tolerance. This is your actual or ideal, correct? So, you're going to have this. Your equation is going to be x minus what you hope it is. Absolute value is less than or equal to the tolerance. Does that make sense? There's what you hope it is, or actual is, and that's your tolerance. Okay? This is an AND problem, yes or no? Huh? So your first equation is x minus 2.50 is greater than or equal to negative 0.05. And the second equation, copy it down without the absolute value symbols. And I'm going to solve this equation. I get x is greater than or equal to 2.45. And add 2.5, so I get the second one. And add 2.50, I get x is less than or equal to. Glad you're here, Wyatt. How you doing, bud? Everything good? Awesome. Okay. Agreed? So then, if we wrote it like this, that look right to you guys? This right here, you normally write it like this, don't you? Okay, it says that write an absolute value inequality to represent the problem, so there's that. Then it says, which rod will you pick? Which one would you pick? Which one fits in between these two? 2.44 is to the left of 2.45, isn't it? This one here's too big, isn't it? Wouldn't it be C? Does that look right to you guys or not? Which one would it be? A? Yep, the A. And what else? And C? 2.484 would be, yep, I agree with you. Those two values are in between there. Okay? Turn page. Does this make sense or not? This is an application of an and problem, is what it is. And its tolerance. Okay. I'm not going to do that. It says this. Let's go to example 2. Okay. The thickness of mats used in the ring parallel bars and vaults must be between 7.5 and 8.25 inclusive. Inclusive. Okay, so let's think about this. This time, we have the minimum value and the max value of the interval. Not the mean and tolerance. We don't have the middle. That's between the min and the max, correct? The formula says means extremes. How many remember that from geometry, means extremes? It's means extremes is the average. So if this is the minimum value and this is the maximum value, how would you find the mean? Which is average, yeah. Add the two together and divide by what? 2, okay? So the mean is equal to 7.5 plus 8.25 divided by 2. And I end up getting 7.875. Correct? Now, so here's what we have. Here's the number line. Okay? Okay, we have 7.5 here. Here's our mean, which was 7.875. And then here's our maximum value, correct? So this is right in the middle. Here's your least, here's your greatest. So our tolerance, does everybody have to agree, has to be from here to here or from here to here? They're going to be the same, right? They're going to have the same distance. So how could I go about finding this length from here to here? Somebody said it, I heard it. Subtract. Agreed? Subtract. So, if we want to get from here to here, it would be 8.25 minus 7.875, which I got when I did it, 0.375. What's another way I could do it? Couldn't I subtract these two here? Wouldn't I get the same value? Because aren't they the same length from here to here and from here to here? So I could do it either way. I could take the mean and subtract as well, couldn't I? And I get the same thing. There's your tolerance. Notice, did I get the same thing? So this distance from here to here is 0.375, isn't it? Agreed? That's your tolerance. So now we can write our equation. X minus 7.875, absolute value. This is always going to be X. This is always going to be subtraction. That is your ideal. That's your middle, right? Your mean. Correct? And then what did we find for our tolerance? What did we find? 0.375, correct? So there's your equation. This makes sense? Kind of? Clear as mud? Okay? All right, let's do the last one, then we're done. We got done early today. Steel rods produced at a factory must be 10 inches long. That's your ideal, or your actual. With a tolerance. There's your tolerance. This one's an easy one, isn't it? The one that's hard is when you're given the least and max, aren't you? You got to find the average. Agreed? Okay. So, what's your ideal? So that's going to be x minus 10 absolute value, correct? And less than or equal to, what's your tolerance? Pardon me? 0.2, correct? There's your equation. This has to be minus. This has to be less than or equal to. So which one is it? C, isn't it? That look right to you guys? This is always going to be minus. Okay? This is always going to be less than or equal to. Always. And that is your tolerance. Those will always be the same. Feel pretty good about this? So that's easy, isn't it? When they give you the ideal or actual and the tolerance. That's easy, isn't it? The one that's harder is when they give you the least value and the max value. You got to find the mean, then you got to find the tolerance too, correct? Okay, I'll let you work. I've opened up those assignments, including the test review.